Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss our first tutorial in Chapter 2 Thermochemistry, Week 3, Hour 1 for both NFTF and FTF questions. So at the end of this lesson, you should be able to define and write thermochemical equations, to sketch the energy profile diagram for both exothermic and endothermic reactions, and lastly, to calculate the enthalpy change. So I want to skip the questions number 1 because we have already discussed about the thermochemical equations and also the enthalpies in our lesson video. So let's just skip to question number 2. Question number 2 asks you to consider the following reactions. So we have hydrogen gas react with half oxygen gas to give you water in gaseous states. There is extra information given in here, which is delta H. Okay, so look at questions 2a. The questions 2a asks you to sketch the energy profile diagram of the above reactions. So let's recall how many energy profile diagram that you need to know. So we have two types of energy profile diagram. One is exothermic and another one is endothermic. So how do we know whether we want to sketch exo or endo energy profile diagram? By looking at the delta H value. If you have negative delta H, means you're going to draw exothermic reactions. If you have positive delta H, means you're going to go for endothermic reactions. So in our case, we need to draw exothermic reactions. In order to draw this energy profile diagram, you must first start with your Y and X axis. So Y axis is going to be enthalpy, while x-axis is going to be the reactions progress. Since we have negative delta H, means that we're going to have larger enthalpy for reactants than the product. So we're going to write H2 and O2 up here. And our product is down here. Then we're going to have our minimum energy required for a reactions to occur. And then we have to label them. So we know that from reactants to the transition states, we're going to have activations energy. So we need to label it as EA. Okay. Next, from reactants to product, we're going to have a negative value of delta H. So our delta H given here is negative 241.8 kilojoule. So you need to write it negative 241.18 kilojoule. Okay, so this is how your energy profile diagram should look like. Alright, so which enthalpy is larger, reactants or product? Of course, the reactants, because it's up here. Okay, for C, for the reactions 2H2O in gaseous states to give you 2H2 gases plus O2 gases. So, they ask you to calculate the enthalpy change under the same conditions. The same conditions here is referring to the previous questions in 2A. Not 2A, but for the whole questions itself for number 2. So, have exactly the same reactions, but reverse reactions. So, what can we say about these reverse equations? They still got H2, they still got O2, and they still got H2O, but the difference is just the positions. So once the equations is reversed, then you need to change the sign of this enthalpy. Apart from that, the number of mole also changes. So once the number of mole also changes, it will also affect the magnitude of your delta H. So by using the informations we have in here, we need to apply it to our targeted equations here. So initially we have negative 241.8 kilojoule. Then once we reverse it, they're gonna be positive 241.8 kilojoule. And once we times all the species with 2, then we also need to times this with 2. So lastly, you're gonna get delta H of 483.6 kilojoule. Okay, so that's how you do these questions. Now let's proceed with question face-to-face. So at the end of this lesson, you should be able to calculate the heat absorbed or released by a substance. So heat absorbed or released here is denoted by symbol Q. And to calculate the heat capacity of a substance, so heat capacity uses symbol of C or small c. So we have different C means different heat capacity. So now questions number 1 for face-to-face is a 446 gram sample of water is heated from 850 degrees Celsius to 7460 degrees Celsius. Calculate the amount of heat absorbed. So we want to find amount of heat absorbed in here, which is the Q absorbed. Okay, so by the water. So we have informations about water. Then we just need to calculate the Q. So we know that our Q got two types of formula. One is C delta T, another one is MC delta T. So the difference between these two is just one we have mass, another one we got no mass. So for these questions, which formula do you think we will use to calculate the Q? Yep, since we have 446 grams sample of water, then we're going to go for MC delta T. So we're going to write Q is equal to MC delta T. So let's check if we've got all the informations to be substituted into this formula. So we have mass of water, followed by we have temperature. So we have two temperature in here. One is lower in value, another one is higher in value. So we should label it as T1 and T2. So since we have difference in T1 and T2, means we can calculate the delta T. Next, we want to find Q. So what about C? So specific heat capacity of water is already been given in the constant table, which is 4.1 joule per gram per degree Celsius. Okay, now we've got all the informations. Can we substitute the value and find the Q? Yes, so we can simply substitute the value. So our Q gonna be 446 times with 4.18 and then we have 7460 minus 850. Then our final answer would be 12328 joule. But since the questions already asked you to give in kilojoules, then we need to change it to kilojoule by 1, 2, 3 like this. So our final answer would be 123.23 kilojoule. So this is going to be our final answer for question 1. Let's proceed to questions 2. So for questions number 2, we've got informations about lead palette and also water. So we are going to read these questions together and highlight the important points as we go through these questions. So let's change it to yellow for lead palette. So lead palette having a mass of 2647 gram at 89.98 degrees Celsius was placed in a constant pressure calorimeter. So constant pressure calorimeter here is just a setup of these experiments. Okay, and then that is negligible heat capacity containing 100 ml of water. So this 100 ml belongs to water. And then another information regarding water, the water temperature rose from 20 to 50 degrees Celsius. So we can see the initial temperature of lead is 89.98 degrees Celsius and the initial temperature of water is 22.5 degrees Celsius. So what does this 23.17 degrees Celsius means? The 23.17 degrees Celsius is the temperature that both lead and also water have shared. So we're gonna put two colors in here. So we have half is green and other half is yellow, so that we know that they're going to share this value. So now we want to calculate the specific heat capacity of the PB pellet. So this specific heat capacity is denoted by small letter C. Okay, so since we've got two different situations in the same setup, then we need to imagine a bit how does it looks like. So imagine we have a beaker down here. So the beaker is filled in with water. Okay, so the water, we have water in here, and also we have some PB pellet. Okay, so we have the lead pellet down here. So we know that the initial temperature of this PB pellet is 89.98 degrees Celsius, and the final temperature once it has been dipped in the water has become 23.17 degrees Celsius. And what about the water? So the water initially they starts with 22.5 degrees Celsius, and it lasts with the same temperature as in lead pellet, which is 23.17 degrees Celsius. So the one that the temperature has dropped will be the one that absorbs heat, and the one with temperature increase will be the one that releases heat. So we're going to use the formula of negative Q release is equal to positive Q absorbed. How to determine whether water or lead pellet will release heat or absorb heat? So if we have a reactions like neutralizations or combustions, the one that is reduced in terms of its temperature will be the one is absorbed, while the one that has increased in the temperature will be the one who releases heat. But for these questions, we only have water and also lead pellet, so that there's no reactions is taking place between water and also lead pellet. So there's only heat flow where they are going to transfer heat to one another. So for this type of relationship, we're going to say that lead with initial temperature of 89.98 going to be the one that release heat, while water with initial temperature of 22.5 with lower temperature than the lead will be the one that absorb heat. Okay. So now we're going to apply the expansion of this formula where our Q gonna be negative MC delta T. Same goes to the water where we have MC delta T. So this MC delta T with respect to each substance. So we're going to substitute the value that have been given in the questions. So we have mass of PB pellet of 26.47 gram. And then we want to calculate the specific heat capacity of this lead, followed by the change in temperature between the final temperature of 23.17 minus initial temperature of 89.98 degree Celsius. So don't forget the negative sign here. So we need to put it at the very front of these expressions. If you forgot to place this negative sign, you might get negative value of C. So basically, specific heat capacity will only have positive value. So our mass of water is 100 gram. The specific heat capacity is 4.18, followed by final temperature of 23.17 minus the initial temperature of 22.50. Okay, once we rearrange and also we set this specific heat capacity of lead aside, then we're going to get a value of 0.159 joule per gram per degree Celsius. So this is our specific heat capacity for lead pellet. So that's all for today's tutorial. I hope you learned something from today's lesson. So yeah, thank you everyone.